Okay. Um, we are back, and as promised, I was going to give you guys a little video over the exponential word problems that we talked about in class, but only a little bit briefly. So I wanted to make sure there was no confusion about which equations to use and such. All right, so let's dive into some of our word problems that we've been doing. Okay. So there's three key formulas that we've been learning in our exponential equations. Okay, so first is the compound interest formula, and this didn't really copyright when I was going through. This should be divided. So let's erase this, and this would be r divided by n. Okay, so our a p to the 1 plus r divided by n to the nt. So what this has to do is this compound interest. So interest rates are always per year. Okay, so what happens sometimes is we compound it multiple times a year. Okay, and that's what this n is. So the n stands for the number of times we compound something. So something is compounded. Okay, so compounded means we apply part of the interest at that particular time to what we have in there, and then that number grows, and we make interest off of that new amount of money. Okay, so the more times you compound things, the higher the amount of money, or the higher the amount of whatever it is that you're going is going to increase. Okay, so always remember P is what stands for the principal. So the principal is the initial amount of money that you put in. Okay, so this is the initial amount of money. Okay, and then T is time. Usually time is in years, but it does change problem to problem, so you might want to just double check what everything is. And then A would be the final amount that you end up with. Okay, so here's the compound interest. Now, there are moments where you actually compound things continuously, and that we use our exponential function. So this fun little e right here, which again stands for Euler's number. Okay, so e is something that we use to model things that are going continuously. So things like the stock market would be a continuous compound interest because it's constantly moving as people trading at all times during the day. We can model it through that exponential formula. Okay, and then our standard just exponential change with percent increase and decrease. Okay, where t is the number of periods the amount changes. Well, t would be the time. So yes, t would be the number of periods this amount changes. So t is the amount of years that something is going to go. Okay, and then a equals a naught is another way of saying principal. So this is another way of listing your initial amount of money. Okay, and then to the 1 plus r. So r is again your rate, and then t would be the time. Okay, so exponential change would be things like if your car value is depreciating, so per year it's depreciating by a certain rate. Okay, or if population is growing at a particular rate per year, as we model it through an exponential change function. All right, let's look at some actual examples, and then we can kind of apply these, because the hard part is applying these to a particular problem. All right, so as we look at these examples, we always want to look for keywords. Okay, so we have Ramel has saved $4,000. So $4,000, that's the amount he has saved. So that would represent what would be our principal. Okay, and he plans to deposit it in an account earning 1.5% interest. Again, that is our rate. So this is per year, but he's compounding it quarterly. So compounded quarterly means I should be using my compound interest equation. So A equals P times 1 plus R over N to the NT. Okay, so compounded quarterly means my N value is 4. Sorry, that's supposed to be an arrow. Pen slipped a little bit. Okay, so N would be 4, so quarterly 4 times a year. So assuming he doesn't add any more money, how much money would Rommel have in the savings account after 5 years? So this is just plugging it into our formula. So we're going to slide this over. We'd have 4,000 times 1 plus, this would be R, I'm sorry, R would be interest, so that would be 0.015 divided by 4, 4 times a year, to the 4 times 5. All right, and then we would plug this into our trusty little calculator. It would be 4,000 to the 1 point, so 0.015 divided by 4 gives you 0.00375, and that's to the 20th power. So then we're going to plus 1. 20th power gives you 1 times 4,000. And at the end of that time, he would have $4,310.93. All right, so then how much money would she, I'm sorry, I keep calling her he, it must be, okay, would she have if she invested her savings in the stock market for that time, which historically draws 7% annual interest? So let's say she put her money in the stock market. Now the stock market, again, we use our continuous interest. Okay, so whenever you see stock market, we want to think continuous. Okay, so that's A equals P e to the RT. Okay, so now we're going to put this in the stock market. So we're going to have 4,000 e to the 0.07 times 5 years. All right, so 0.07 times 5, and then e to that power, and then times 4,000. And she would have $5,676.27. So obviously, with a much bigger amount of interest rate, she's going to earn much more money than if she just puts it into an account. Even though this is compounded quarterly at only 1.5% a year, she's not going to be earning as much money. Okay. All right. Let's look at another one. Okay. So here a scientist is growing bacteria, starting with a culture of 5 bacteria. Okay. So again, this is my starting point. So this is our initial, amount of bacteria. The colony of bacteria doubles every 2 hours. So write an exponential function that relates the time in hours to the number of bacteria using a base of 2. The reason we're using a base of 2 is that it is doubling. Okay, so doubling is basically we're sitting here and our 1 plus our rate would be 100%. So we get 1 plus 1, so our base is going to be 2. So hence why it's talking about our base of 2. All right, and then it says the petri dish has an area of 58 centimeters squared. The average bacteria cell is a surface of 20 micrometers. How long would it take the bacteria to completely cover? So let's actually just focus on the exponential function right now. Okay, so here we have A equals, okay, so again, we have 5 is our initial value times the base of 2. So this is our doubling rate, and it doubles every 2 hours. So I want to do T divided by 2 because every 2 hours is what I want. So every hour, it's only actually going to put half of what it was. So it's going to take the full 2 hours to be our whole numbers. Okay, so T divided by 2. Okay, so we want to know how long will it take for the bacteria to completely fill up the dish. Okay, so first off, we got to figure out how many bacteria we can actually fit in here. So here we have 58 centimeters squared. Okay, and then we have an area of 10 micrometers. Okay, or this is 10 times 10 to the negative 6 meters squared. Okay, so actually this, we want to use 0.005 for meters. Okay, and then we're going to divide into that our 10 times 10 to the negative 6 for our bacteria. So let's whip out our old fun trusty calculator. So 0.0058 divided by 10 e to the negative 6. Where's my negative on my phone? 6. And looks like I can hold 580 pieces of bacteria. Okay, so if I want 580 pieces of bacteria, I look at and I say, all right, so I want 580 equals 5 times 2 to the t over 2. So we're going to take 580, we're going to divide that by 5, and I get 116, 2t to the t over 2. Now, when we have a variable and an exponent, this is when we want to take the log both sides. So I would then get natural log of 116 equals t divided by 2 ln of 2, and slide this over, divide both sides by ln of 2, and I get t over 2, and then I'm going to multiply both sides by 2. Okay, and should give me my time. So I'd have 116, take the natural log, divided by 2, natural log, equals times 2, and my time would be, 13. Let's actually write this so we can all read it. 13.72 hours, right? This is all in hours? Yes. Boom, just like that. Okay, so it's important to just set up and, again, understanding which equation we're doing and looking at those keywords. Okay, all right, well, this is fun. Let's do another one. Okay, so here we have our fun topic of half-life. Half-life is another way of something happening continuously. Okay, so we're going to do the decay of bromine 85. Okay, so the half-life of bromine 85 is 3 minutes. Okay, so as it says, if we had 60 grams of bromine, 3 minutes later we're going to have 30, and it's going to constantly be breaking down in half. Okay, so we want to write an exponential function that calculates how much is going to be left after t minutes if the initial amount is 60 grams. So the first one would be a equals 60 would be my initial amount, and then e to the rt. Okay, because this, every time you see half-life, this is also an this is an e to the x situation. This is a continuous thing. Okay, once something starts breaking down, it's going to break down continuously as we move through that. Okay, so now we want to estimate how much is going to happen after 20 minutes. But the key thing here is we don't know what our rate is. Okay, so we're going to have to figure out what that rate is. So the way you can do that is, well, they told us that after 3 minutes, we have 30 grams. So I'm just going to put our time in minutes. Okay, so 30 equals 60 e to the r times 3. Okay, so after 3 minutes, I have exactly half. Okay, so this is 1/2 equals e to the 3r. Again, take the natural log of both sides, and I get natural log of 1/2 equals 3r ln e. Ln e is just 1, so ln of 1/2 divided by 3 equals r. And 0.5 ln divided by 3, my r is going to be equaling to negative 0.231. All right, so now I can put this into my equation at a equals 60 e to the negative 0.231, and now I can solve for after 20 minutes. So I can sit here and say, all right, so if it was 20 minutes, to that power times 60. How much will be left? So after 20 minutes, there's only going to be 0.591 grams left of my bromine, because that is decaying just that rapidly. Okay. All right, so hopefully this gives you a better sense of how we're going to go through these exponential equations. Definitely make sure you're asking as we start reviewing here towards our test next Wednesday or Thursday, depending on if you're a gold or burgundy kid. And hopefully everything goes okay. All right.